Hi everyone, this is Anusha and I'm here with my colleague Ankita. So basically we're from Ironworks and we have been working on self-sovereign identity around here. So today we are going to take the center stage and talk about SSI, that is self-sovereign identity. So today's agenda is divided into three parts primarily, where in the first part we're going to focus on what is identity, how has it evolved over time, what is so critical about identity that it needs to be secure. Then moving on to the part two will be the main focus here is
SSI, of course.
Yeah, it's about SSI. What is SSI? Then need for SSI, then components that are associated with SSI. Then are there any tools already available in blockchain that can aid in the implementation of SSI based solutions, and where all can SSI find an application? And then we'll move to part three, which is basically just a glimpse of our product, Credible and Adaya. So moving on, the first part, that is unfolding identity. So basically it's an outer structure of what identity is. So what is identity? An identity is a representation of who I am, where I am from. It is basically whom I relate to, who belongs to me, what I do. It's my name, it's my birth date, it's the every credential that's associated to me forms my identity. So what is the problem with identity today? That it's mostly paper. So we divide identity into two parts or into two categories widely. That's paper-based identity or physical identity and digital identity. So moving to the phase of paper-based identity or physical identity, anything that you can carry with yourself or which is a hard copy, like your Aadhaar card, your PAN card, your college ID card, your organization ID card, everything is an identity, physical identity. So what is a credential? In digital world, they're called as credentials, the identity cards. And moving on from here, what is the risk here? If any of your identity card is stolen, it's worn out, it can be tampered with, it's only verifiable manually, like only a person can verify it, and the verification is also not a foolproof verification. So these are what we see as hindrances in the physical identity world. Moving to the digital identity world. Now, what is digital identity? Something that you can carry on an electronic device, that is your phone, your laptop, etc. So what will be the representation of digital identity? A representation of digital identity will be your Gmail account, will be something of a, e-verification documents. It can be your Facebook accounts, etc. So all these things come under your digital identity. These identities have more access to your life and to your data than physical identities. So again, what is the down point here, or what is the point of what is the point here is the digital identity holds a lot of data, and if compromised, it can cost you a lot. So moving on, digital identity as it evolved. So basically, how has the evolution taken place from the digital world? So first was the siloed or the centralized identity. That is you, an account to an organization, right? So what is centralized identity? This identity is owned by someone else. So suppose, for example, the basic example can be a Gmail account. You ask Gmail to provide you an account. So basically, Gmail is your third-party provider. Your access is controlled by Gmail. You do not control the access. So that is the siloed or the centralized identity version. Next is the third party or the federated identity system. Now, what do you do with your Gmail account? You log into third-party applications like Facebook. You log into your shopping applications, e-commerce applications, your ticketing applications. You use your Gmail, primarily you use your Gmail accounts for that. So basically, there is an identity provider. You use that identity provider to log into an organization. So that becomes a federated identity or a third-party identity system. Now, moving on, from federated identity. So if we go back and we look at what are the shortcomings of these systems. First, you do not have ownership of your identity. It is your identity, you should own it, but somebody else is owning it. Who controls it? A centralized agency. As in case of a Gmail ID, Google controls it. Single point of attack, honeypot. Next, the cases of identity theft. All of the people present here are, I guess, very well aware about the identity thefts happening around us, be it the Yahoo hack, be it the LinkedIn theft, be it the Facebook hack, etc. So identity thefts have been becoming a usual now. And what is the reason behind it? It is the digital identities existing. Next, user profiling using data linkage, scattered identities, and lack of portability, outdated or stale data, no consent management, which is a very important point, that before sharing my identity with somebody, I do not sign any consent here, or consent is not taken from me at every step. No selective disclosure of information. There are privacy issues. Claims are not instantly verifiable, and it's costly and delayed verification, and the list goes on and on and on. Therein came a solution, that is self-sovereign identity. What self-sovereign identity is? It basically states that I control my identity. No one else can share it. No one other than me can own it. My identity, I have full access of my identity. It is a peer-to-peer based system, and it is definitely linked to blockchain. So basically, blockchain by design is a secure system, right? So if we integrate digital identity with cryptography and blockchain, so we enhance it with two main foundation stones, that are immutability and security, which is a necessary foreground to avoid identity thefts. So basically, SSI gave us some principles, and those principles hereby are existence. That is, users must have an independent existence of their own on the network. Second, control. Users must control their identities. That is, I control my identity. Third, access. Users must have access to their own data. That is, users must have access to their data anywhere possible. That is portability. Fourth, transparency. That is, the system and algorithms must be transparent. So by using blockchain at the base, we're making the system transparent. Fifth, persistence. Identities must be long-lived. They can be updated, but they should exist. They should be persistent. Portability. Information and services about identity must be transportable. Interoperability. Identities should be as widely usable as possible. They should not be restricted by any borders or any networks. Consent. Users must agree to the use of their identity. That is, if any organization wants to use my identity, I should be the one agreeing to the fact that they can use it. 9, minimalization. Disclosure of claims must be minimalized. And last is protection. That is, the rights of the users must be protected. Now, moving on. Based on SSI, we came across a study from Gartner's, and here are the results around the hype from Gartner's. So Gartner's did a survey that focused on engineering trust, accelerating growth, and sculpting change. Out of the many emerging techs based on blockchain, including NFTs, ERC20s, and other technologies, augmented AI, etc., there was some points that came out as our center points, out of which decentralized identity and digital humans, 2 points are what are under our talk today. So what is important is the fact that Gartner projects that by 2023, approximately 35% of enterprises will be connected to DApps. Now, what happens when an organization connects to a blockchain application or a decentralized application. You need to secure identity somewhere from this, right? The identity will play a major role in it. So W3C defines some standards around it, known as the SSI standards. And now is the time to ride that wave so that by the end of 5 years or so, you have a foreground with SSI based solutions ready. So I'll hand over the mic to my co-host Ankita, who will take this session further with the SSI based solutions.
Thanks, Anusha. So now you have a few details of what identity is, how identity is evolved, and what is digital identity, how it is evolved, and all the things. So why to trust this SSI ecosystem? So the standards that SSI follow is all the open standards. So emerging SSI open standards, it includes the W3C. It's an standard open protocol for having unique, private, secure connections. So there are organizations which are involved in working towards standardizing these technologies over across the web. First is W3C, World Wide Web Consortium, which gives two standards, that is verifiable credential and DID, decentralized identifier. We'll have a look at both of them in subsequent slides.
Please.
The other standards which are in SSI stack is decentralized key management system. So how the encryption keys are managed, where they are stored. So all this comes in DKMS. The next is the authorization. So these are some emerging open standards that are part of SSI ecosystem. We'll first have a look at what is decentralized identifier, the basic, the foundation of SSI, what it is. So a decentralized identifier is any identifier which you see on web, they are URIs basically. So URI is all the web identifiers comes under URI. We see some network locators that are URLs, and some the other category is URNs. So URNs are persistent name, they never change, and URLs are locators to a location or to a web page on the web. So DID falls under URN. It is completely in line with web architecture that we have. Since web is not limited to a certain type of URIs, so DID, decentralized identifier, came as a new identifier which will run over the web. So it's basically a unique identifier which is persistent, and it is not regulated by any centralized authority. So DNS, as Tim Berners said, that DNS is an Achilles heel of the web. So better web built on this new type of identifier that we have. SSI have different components: agents, wallets, credentials. So you need a name, you need an identifier to talk to each other. So if I have to give a letter to someone, I should have an address of the person. The same way identifier DID works for a decentralized application or a SSI based application, you can say. So DID has multiple components. One is schema, method, and identifier. So identifier is basically the address that cryptographically generated the address of a identifier. So this is basically what DID is, how it is built, and what are the components of a DID. So for building any relationship, you need an identifier. You need a number, name, address that you can refer to someone to exchange your message. And that's what they do in SSI space. There are some, what is so special about this DID? There are so many identifiers over there on the network. So first is a person can have as many DIDs as he wants. A DID is, as I said, it's a URN. So it's a persistent identifier. It never changes. And since it is a cryptographically created one, it is encrypted, and you can have a private channel to talk to some other party. There are so many URNs out there which are persistent. The next feature of DID is it is resolvable. Resolvable means you have registered it on a public network and you can go and have a look at it. There are so many HTTP URLs that are resolvable, as we know. A DID is cryptographically verifiable. There are so many IDs which are created cryptographically. Just like I can give you an example of IPFS. So IPFS is also having an address which is cryptographically secured and decentralized. So no central authority or registration authority is there. So for example, currently we have UIDs, those are also decentralized. But identifier that has all the features in it, it is DID. So DID has all the core properties over the as an identifier, which makes it so special. So what goes in DID, how it is related to a person in a real world. So basically, it is an identifier. As I said, an identifier can be anything, a name, number, or address for some kind of interaction, to resolve it, to access it. So basically, a DID can relate to any person, anything, or anything, any object, or any person. When you write a DID on a blockchain network, it has a property, a metadata to it, which we call it as a DID document. You can resolve a DID from any ledger and you will get some details about the DID that is created, the identifier that is created. So you'll get the information of by which way cryptographic method this DID is created, on which network this DID is, what is the authentication method of this DID, when the DID is generated, and what are the services that are provided. So where this DID is actually tagged with. So this is a triangle which is represented here, where a DID document, it describes a DID subject. And this is the example of a DID that resolves and get this DID document. So how you will get the identifier, the details of the identifier is using a DID document. So in SSI, the second thing that will look into today is verifiable credential or verifiable claims. So we got the identifier. We got a unique identifier that is persistent and that will be with you for lifelong, and that is secured and enabled by cryptography. But how to use that DID? Where you will use that DID, and what is how to exchange messages and get credential using that DID. So there are DID enabled digitally signed verifiable credential. The standards are led by W3C, and it involves issuing a credential. So what a credential is? Credential is something, as Anusha explained, that how to prove myself. Who am I? What I have? This is the identity. Identity is credential that proves what you are. So proof of something is a credential. And there is a terminology originated from W3C called as verifiable credential. So verifiable credential is nothing but a digital attestation of a credential by any owner, identity owner. So any identity owner, we call it as holder, that secure or that has the credential with it. The credential is issued by an issuing party, an issuer, and the metadata of the same issued credential goes to a verifiable data registry, that is a blockchain, the single source of truth that some credential is issued to a holder. The verifier can verify the credential that is being shared by the issuer to the holder. So in SSI terms, we call it as a trust triangle, where it includes three parties. What it needs to have a verifiable credential? There must be some issuer, some issuing authority for the credential. There must be an holder which holds the credential which is being issued. And as and when required, the holder should be able to present the proof. A issuer will issue a credential and holder will secure the credential and send a presentation to the verifier. How the verifiable credential is shared. So one of the feature that SSI brings in with the credential is it can be disclosed selectively. Just like if I went to a restaurant and if I want to prove that my age is above 18, as of now, I have to show one of my identity card that has all my details, including my residential address, my name, date of birth, and everything. But why I'll need to share so much of information when it is not needed? I just have to prove that I am above 18. A simple question should have a simple answer, yes or no. That is what SSI enables. We call it zero knowledge proof. So zero knowledge proof is, let's say if a prover wants to prove something and a verifier don't know that if he has the credential or not, but a prover can just give a simple answer to a simple question in a Boolean form, true or false, whether I am above 18, yes or no, without sending any more information or more details about the credential which I have. I can have driver's license, I can have national ID, I can have my birth certificate. So these are the details which are access to share and which is not needed to share. So, zero knowledge proof, it is a method by which one party can prove another party about the details they have without actually sharing the information apart from what is asked for. And it can be anything. In the exam, in my case, it was age. It can be your password. It can be the detail of whether you are a resident of this country or not. So it should have an answer, true or false. That's it. That is what SSI enables. That is what decentralized identity enables. Sharing the data selectively. So we went through what SSI is, what are the standards that SSI follow, what is the identifier that SSI revolves around, and what is the concept of credential and verifiable credential. So how to implement SSI? Are there any frameworks, any tools available to implement the concept of SSI with blockchain? So Linux Foundation has started Hyperledger Indy framework, which is a ledger purpose built for decentralized identity projects. Then you can see a tool called Hyperledger Ares and Hyperledger Ursa that are supportive tools for building a decentralized identity system. Let's go a little deeper into what these three frameworks and tools are and how they support building decentralized identity application. So Indy, as I said, it was built for decentralized identity. It enables the usage of zero knowledge proof technology that I just mentioned, and it enables the creation of decentralized identifier, DIDs, the building block, the basic building block of SSI. And it provides distributed ledger as well for storing the metadata and supportive things of the ecosystem. Hyperledger URSA was a project that was started to support all the cryptographic package that are involved in creating all these identifiers, credentials, proofs, and claims. So URSA has all the cryptographic algorithm to create the decentralized identifier. The DIDs can be created in various algorithms. And the verifiable credential, they have a part where you have to generate proof out of it. So verifiable credential has a part of the user's private, the cryptographic material and the issuer's cryptographic material. So all these cryptographic packages are built under Hyperledger URSA. It includes all the signing, verification, encryption, decryption, and hash generation and encoding, decoding. All the packages are wrapped under URSA. Next is Hyperledger Ares. So you can say Ares is equal to agent. So we need someone to work for us on behalf of us. On a digital era, we can, as a human, we need our representation on the system, which will work on behalf of us. So who does in the SSI space? These are agents that does. So SSI agents are basically tools that that can be on behalf of any identity owner. So what an identity owner is? Someone who has a control over the identity or over the credentials. So that is an identity owner. So so an agent is a tool that act on behalf of identity owner, that holds all the keys of the owner. It can be an owner, can be an individual, an organization, a device, or a thing. It can be anything. So agent is something that that works on behalf of an identity owner. It involves all the cryptographic keys and includes and holds all the cryptographic keys of the owner. And it communicates with other agent to send a message, to receive a credential. So these are the communications that holds. All these communications are DID secured. The decentralized identifier that we just talked about. So all the communications are DID secured. That's why we call it as DID communication protocols. So all the encryption messaging system, implementation of Indy zero knowledge proof and DKMS falls under Hyperledger Ares. So these are the three frameworks and tools by which you can implement a SSI based system or a decentralized identity application. Now, where all these decentralized identity systems or SSI can be used? If we'll think an enormous, there's plethora of use cases where we need to have a secured identity, a credential that cannot be falsified. Let's say your health records or your degrees, your certificates, your identities or passports. They should not be falsified. If they are issued to someone, it should be constant for till the date they are not revoked or they are not expired. So there can be enormous use cases of SSI where it can be used, from very basic need of your courier, your package, to a very vital information of your health records. Your financial records can also go on SSI, because your bank statements, your identity, financial identities needs to be secured. Your email accounts, anything and everything can have something which is tagged with an identity can be used to have a secured credential with it. Anything else? So we talked about how to build SSI systems, what are SSI systems, what is self-sovereign identity basically, how it is used, why it is useful, and what are its applications. At Ironworks, we are building SSI-based self-sovereign identity-based system platform. We called it as Credible. That is a platform for issuer and verifiers to issue, verify, and revoke credentials. And we have a mobile application called Adeya that can be with the users, by which they can share the information, the credentials that are being issued in a selectively disclosable manner, or and in a consent-based ecosystem. So I would like to have a quick demo of how the system
Hello,
works.
everyone.
And it will give you a brief about what the use case is. One of the use case we have taken here, and it will give you a brief about what the use case is, how SSI system can be implemented.
Blockster Labs, product division of Ironworks, is glad to present most innovative technology, namely decentralized or self-sovereign identity, abbreviated as SSI. We will understand in detail about SSI in the last part of this video. Before that, let's go through the demo first.
Alright, the demo we have brought to you today presents a simple solution to issue and store COVID-19 test report as a digitally verifiable credential. Yeah, you heard it right. A digitally verifiable COVID-19 test report. In this example, Medilab, being licensed to carry out COVID-19 tests, first completes a one-time configuration of a schematic template that will be leveraged to issue credentials. Individual who needs to get a COVID-19 test report downloads and sets up RDR mobile app in quick and simple steps. He then connects with Medilab by simply scanning QR code published by them. Once COVID-19 test result is available, Medilab issues this report as a verifiable credential to the holder, which holder stores in his wallet in a secured manner. Let's say that local corporation needs to verify the COVID-19 test report of the individual to provide any social services. It connects with the holder and sends him a proof request. In response to this, the individual holder generates proof from his COVID-19 test credential with a simple click and sends it to the corporation. This proof gets verified by the corporation in a lightning way. So let's jump into the demo of Credible platform right across.
This is the Credible platform. Lab technician from Medilabs logs in. As a one-time first step, let's create a schematic template that will be used later on to issue verifiable credentials to the individuals. To create the template, specify template name, which in this case is COVID-19 test report, then specify version number, followed by attributes such as first and last name of the person being tested, date of birth, date on which test is being conducted, sample type, and most importantly, test result. These attributes reflect in the credential on individual's wallet.
So this is basically the template of how a credential will look into individual's wallet. So if a verifiable credential is issued, there must be some template which is which back the credential which is issued. So this is a creation of the same template for one of the VC that is going to be issued.
Let's store this template quickly.
And this template is stored on Ledger, on a blockchain ledger, Hyperledger Indy in our case. It makes it verifiable, the template as well. So whether the attributes which are being issued are legitimate or not, where these are the same attributes which should be issued as a part of test report.
Now we will tag this template with Medilab's name. This just makes it easy to identify that Medilab is the issuer. Now store this tag name, and that's all. We are ready to start issuing credentials. Meanwhile, individual citizen downloads the Adea mobile app and completes the one-time setup by keying in some of the personal details such as first name, last name, and email, followed by a 6-digit PIN and either fingerprint or Face ID as a biometric ID, just to have an additional security layer for accessing his mobile wallet. He then verifies email ID by providing the one-time passcode received on his specified email ID. Once the email ID gets verified, Adea app sets the wallet for the user, making it ready to receive connections and credentials.
However, before this can happen, wallet user will need to first connect with Medilab. He can do so by simply scanning QR code provided by Medilab and submitting request to connect. Now, with the secured connection established between Medilab and the wallet user, Lab issues the COVID-19 test report in the form of a digitally verifiable credential. To do so, lab technician chooses the specific template, provides all the details for each attribute in the template based on the results from the actual test conducted. These details, if you recollect, are first name, last name, date of birth, test date, sample type, and test result.
Wallet user gets notified of having received this credential on Adea app. User can open the credential and view the details received in it. Once he is satisfied with the details such as legitimacy of the issuer, information provided in the credential, user saves this credential card in the wallet for future reference. Now, let's see how local corporation can verify COVID-19 test report of the individual.
So till here, the issuance part was what you saw. So there was a mobile holder and there was an issuer, a lab, which issued a verifiable credential to a mobile holder. All the communication happening between these two entities, they were DID secured. We call it as DID communication. And now the next part is when a verifier comes into a picture and he wants to verify the credential that is being issued.
And for that, the individual must establish a connection with the corporation, which is done by simply scanning the QR code, just the way shown earlier. Now that they are connected, corporation authority sends proof request to the individual. To do that, he pulls out the same template, selects the attributes that need to be verified, and sends this request to the individual. Wallet user gets notified of this request, checks its legitimacy by viewing the details, and after being satisfied, sends proof in response by simply clicking on a button. Corporation authority gets notified on the credible portal about the proof being received, opens the proof and verifies it, again with a click of a button. That's simple it is.
Thanks for watching the demo of Credible Platform.